on what it is all about. So here's the next one. This is, no, this is not today. This is yesterday. I showed you two yesterday. So the problem for yesterday was this. You are 36 miles from a friend. You both start riding your bicycle toward each other at the same time. So at the same time, you both start and heading toward each other. You travel 15 miles per hour and your friend traveled 3 miles per hour slower than you. How far will you travel before you meet your friend? Okay, did you hear that problem? Okay, I'm going to switch over once again. We're all good, right? All right, so I'm going to have a couple questions to ask about the problem. Hopefully you'll tell me what the answer is. So let's take a look. First of all, this is you. I would definitely draw a picture once again, and this is your friend. How far are you apart from your friend?
36 miles.
So I'm going to go ahead and draw a line representing the distance, and this line represents 36 miles apart. Okay, so there it is. This is your scenario. Do you know how fast you're going? How fast?
15 miles and 12 miles.
Oh, where do you get the 12 from? I didn't see the 12. So where do you get the 12 from?
3.
Ah, why did you do that?
Because it said 3.
Okay, so because your friend's going slower. Very good. So wouldn't it be fair to say this? If this is your halfway mark, do you think you're going to meet your friend on your side or over to your friend's side?
Over to your friend's side.
Why?
Because you're going faster.
Very good. So if I'm going to have to draw a line representing your distance, is it true that you will probably meet your friend over here?
Yeah.
This is where you two will meet. Right? just, it's okay. Okay. Alright, so this is where you and your friend will meet. And once again, we always start with this. Remember that this is distance equals rate times time, right? Do we know the rate already? Yeah, we know that you're going at 15 miles per hour and your friend is going at 12 miles per hour, right? So you know your rate and you know your friend's rate as well. So let's do a guess and check problem again. I think this is a good problem to do that. So let's do a guess and check. Let's pretend that you and your friend left at the same time, and it is 1 hour later. How far did you go 1 hour later?
20 miles.
You? If you're going 15 miles per hour, 1 hour later, how far did you go?
15.
Yeah. So isn't it true that, once again, this is you. So I'm going to use distance equals rate times time. Your rate is 15 miles per hour, and I said I'm assuming that you only spent 1 hour riding the bicycle. So that means after 1 hour, you cover 15 miles, right? Is it true? And your friend, on the other hand, same formula. This formula will work for every case, right? So your friend's going at 12 miles per hour for exactly the same time as you, 1 hour. That means after 1 hour, your friend will travel 12 miles. So look at this. I want it to be 36 miles apart, right? Will this give you 36 miles apart? No, it's only give you 27. So you know that 1 hour doesn't quite cut it. What do you think your next one should be? 2 hours? 1.5 hours?
Yeah.
Let's try that. So let's say now that you, instead of going for 1 hour, you go for 1.5 hours. Let's do that. Distance equals 15, same rate, but this time it's going to be 1.5 hour. What is 15 times 1.5 hour? 22.5. Very good. 22.5 miles. And then your friend's side, he's going at 12 miles per hour for how long again? 1.5. Remember, same time as you. So 12 times 1.5 is going to get you 18, right? 18 miles. So look, 22 plus 18, 22.5 plus 18 is going to give you 40.5. Wait, is that a little bit more than what I shouldn't have? 36 miles? So I know, at least I know at this point that my time should be in between 1 hour and 1 hour and a half. So I can kind of narrow it down that if my answer is correct, it should be in between 1 and 1.5 hour. Does it make sense so far? Okay, let's think. If you just go for 1 hour, that means you only cover 15 miles and your friend only covered 12 miles. That means you did not, both of you did not cover this total distance of 36 miles. That's why we decided, hey, let's go longer, 1.5 hour. 1.5 hour later, you cover 22.5 miles, and your friend covered 18 miles. That's 40.5. That's over the 36 miles that we said before, right? Therefore, we know that our answer should be in between 1 and 1.5. So now let's go back to the problem and see what we can define. Listen carefully, okay? This is important. From the problem, the question that's being asked at the end of the problem is, how far did you go before you see your friend? Right? And you know that when they're saying that, how far did you go means your distance. Is that true? And distance relies on your speed and your time. In this case, do we have your speed already?
Yes.
But do we have your time? No. The only thing that we know is that your time, you took off the same time as your friend. But there's nothing about time. So because of that, this is the one problem that I need to tell you right now. This is the 1%. Remember I said 99% of the time, the question will allow you to define the variable. But this one right here, you got to think a little bit deeper than that. I know that the question asks about the distance, but the distance requires you to have the rate times time. So it depends on the rate and time. You have the rate, but you don't have the time. So therefore, it is only logical that I also need to find the time first. So I would have to do this. I have to declare t to represent the time of you and your friend. Because both of you are starting at the same exact time. Therefore, t represents both of you. Now look, going back to this. If t represents the time, and you have the rate, your rate. If I take your rate, this is you. If I take your rate times the time, what will you get back? Which is what? What does 15t represent? Distance. Very good. Distance that you travel. What about your friend? Same thing. So your friend now is going to be what? 12 what? T. So this equals to the distance that your friend traveled. Okay. So look. You know that your distance and your friend distance have to add up to what? What's the total distance? 36 miles. So would it be fair to say that your final equation is going to be this? 15t plus 12t equals to 36? And notice the reason we only need one equation this time is because we only declare how many variables? We only declare one. We declare one equation needed. We declare two equations are needed. You see how it works? So can we do anything with the 15t and 12t? Okay, what is that going to get you? 27t. How do I solve for t? Divide by 27. What is t then? 36 over 27 will give you what? Don't give me a decimal, please. Fraction. Fraction. I need fraction. What's that going to get you? 1 and 1/3. Very good. 1 and 1/3 of an hour. Or you can also convert this back to improper, which makes it 4/3 of an hour, right? Make sense? Now look, did I answer the questions from the problem? Not yet. In order to answer the questions, look at this. You got to go back all the way up here in which you define distance that you travel. You got to plug this back into the t. See? So 1 and 1/3, which is 4/3. If you plug it back in, 15, which is you, times 4/3 of an hour, what do you get? What's 15 times 4/3? If you want to do it that way, it's fine. Or you can cross cancel. 20. Very good. 20 what? Go back again. What did you declare up here? Distance. So how do you measure distance? What did you measure? Miles. So you got to read the problem carefully. So if you cover 20 miles, how far did your friend go?
17.
Okay, what's the total distance between you two? 36. If you cover 20 miles, then how far did your friend go? If the total distance is 36. Okay. 16 miles. So this is your friend. So that means you walk 20 miles, your friend walked 16 miles, you will meet head on, face to face at that point. Which kind of makes sense. The picture that I drew up here, notice that you will meet, you will actually cover more distance than your friend. which is exactly how much farther? 4 miles to be exact. Okay, so in the end, you will have to walk 20 miles before you see your friend. Okay? Now, question on this? Okay, good.